All right, so today's topic is pipeline analytics. And because one of the things that Dave and I talk a lot about in the industry is how terminology is thrown around and how confusing sometimes it can be, I wanted to start out with the terms that we're going to be using on a regular basis. And some of these are just naturally intuitive. I understand that, but relate the terminology together because it's important to really understand where we're coming from. The first term that we're going to use a lot of is SDLC, which is your software delivery chain. This is everything that is the strategy, the technologies, the people, the processes, the automation that makes up your planning, coding, and delivery of applications. Then we have this idea of pipeline analytics. So pipeline analytics is getting data and visualizing that data for your delivery chain. Where does that data come from? Well, it comes from your tools. It comes from the tools that you use like Jenkins, Hashi, Spinnaker, Artifactory, PyPy, whatever tools you have in your delivery chain. And it comes in the form, and I use the term broadly, telemetry. Telemetry can be metrics, it can be logs. I'm just going to call it telemetry for now. Dave, is there any definition that I'm missing here that I should have?
Probably not. Yeah, telemetry is the way we move data from where it is created to where we can make use of it. Sort of the broad different discussion point. And as such, that's why you'll hear telemetry used a lot when we talk about observability.
Right. So there's one prerequisite here, and hopefully this is not a stretch of the imagination. A lot of times when we talk about DevOps, we talk about application velocity and we talk about production. And that's certainly where the monitoring and the observability use cases come in. But building applications is much more than that. There's a lot that happens prior to production. And that's the delivery chain. Now, I'm going to suggest, and my pitch is, and hopefully you agree with me because everything I say after this is going to be kind of predicated on this, is that the software delivery chain is also an application. It's an application of applications. Now, there's a lot of things to back this up, but there are some assumptions. The assumptions are that you need to be using code to script your delivery chain. The other assumption is there's automation. Now, it's not always 100% automation in software delivery chains, but that's the goal. Like, that's the target to get to a fully automated delivery chain. If you do that, then truly your delivery chain starts to behave and look like an application. And if it is an application, you should treat it like an application, like you would any application in production. Dave, did you have anything to add to the definition of, or my perspective, I should say, on the SDLC?
No, I'm going to give you this one without arm wrestling.
Oh, yes. Even though debate is always good. So another way to look at this in this analogy that I've been working on is this idea that I don't know if you remember the days of when you didn't have an iPhone that would chart your course from point A to point B. You actually had to print out MapQuest files and you had to try to watch them. Problem with MapQuest is it didn't give you insight and visibility all the way across from where you started to where you were going. Now, if you map yourself on a phone, not only do you see the path, you get to choose paths, you get to see where there's going to be bottlenecks, etc. So we want the same for our delivery chains. But today, most organizations treat their delivery chains like MapQuest. They only understand a point in time. They don't understand from beginning all the way to end. And this is plan, which is where you create your product backlog, to the feedback loop, which is learning by what happens in production after a postmortem, feeding it back in to optimize your delivery chain. And while certainly there are companies who are getting telemetry from their delivery chain, visualizing it and leveraging it, it hasn't been a priority. And so that's really the case that I've been building is making this more of a priority for organizations and truly completing that infinity loop, which goes back to a previous session we did where Dave was talking about the continuous basically everything or the 3 Cs.
There's actually seven C's. The concept is that nothing in this SDLC ever stops. It simply loops back into itself. And what happens with a lot of this is that while you've got this laid out linearly, the respond and resolves are actually my loops inside of here, and that's where things continually reflow and redo this. This isn't a trip you're mapping once. This is a trip you're mapping because you're going to be taking it a lot of times.
Yep. Yeah. And I guess if I were to do that with a road, it would be some weird ass mouse trap in LA. All right.
It's gonna be one of the a Klein bottle of this. Yes.
So here's your infinity loop, and you've seen countless numbers of these, and they start to become cliche after a time. But let me tell you why pipeline analytics matters so much. So, first of all, if your software delivery chain is down, so some component of your delivery chain, testing, your secrets management, your CI CD, if it's down, no code ships. You can't move artifacts. Your SDLC is a part of your attack surface. Some organizations will store secrets in a file in what they think is a secured location. That is a really bad practice, but it is a part of your attack surface. And if somebody gets access to your SDLC, they can get access to your intellectual property via your code repos, and they can find out information about your infrastructure to get access to that in production. So you have to think about that. And that's where we get into this DevSecOps use case.
So, so to add to that, if they can get access to this and they can get access to your code repositories, they can also plant backdoors and
That's right.
time
That's
bombs
true.
into your surface here. And yes, we have seen that happen with code in various places. So protect your SDLC. It's a good line.
Yeah. Yep. Also, big thing, DevOps has all been about getting along, culture, communication across teams. But what we see from a tooling perspective is different teams will use different tools to visualize their data and they start to create silos. And so that causes them not speaking the same language. As all of us know, working in a company, right? Reconciling language, we spend a lot of time doing that. And it can be a major waste of time just reconciling language. So it's important to invest efforts in creating a unified language and giving a platform that supports that. Measuring business value of applications is hard. Wouldn't it be great to know that you launched a new feature and that feature increased your user adoption by X? Measuring success or failure of your delivery chain is hard. So you've implemented this new DevOps thing. You've started, getting all the whiz bang shiny stuff. Is it actually improving your application quality? And is the velocity hurting things or is it helping things? You want to think about getting ahead of technical debt. Technical debt is going to happen no matter what. But wouldn't it be great that you have a tool to help you get ahead of it, or I guess kind of anticipate what the technical debt is going to be? And we have this concept of shift left and shift right, where developers are getting more and more responsibilities, but you can't give developers more work without backing it up with tooling and new processes. And for example, if I'm a developer who's on call, wouldn't it be great to have context that starts from when features are built? Dave, what do you think about the whys of pipeline analytics?
Yeah, I actually really like those. And in particular, your last point as a former developer is near and dear to me, especially microservices environments. Knowing that something has changed in the environment, even if it's not a change I made, becomes incredibly important in helping to determine what the underlying cause is and resolving it. And that is necessary in today's world. Otherwise, and as surveys have shown, in a microservices environment, it's possible for a developer to spend 75% of their time doing nothing but forensics to try to solve a problem.
Yep. That's great. So I already mentioned the silos, and I want to talk about it a little bit again because I think it's really interesting what happens. I'm going to start all the way at the right. If you're a security person, you're an SRE ops person, and not a developer who's on call. Typically, your understanding of the application starts when it's in production. That's your visibility. That's when you start to get telemetry and data in your observability and your monitoring tools. But a lot of times issues go far sooner than that in the delivery chain. And so these silos, while they're very successful within the teams, I mean, we know this. We know that teams are really good at building strong monitoring and observability practices. We know that DevOps engineers are really good at understanding what's going on with Jenkins. And we know that developers tend to be really good and quality engineers tend to be really good at knowing what's going on during their testing processes. But it doesn't span these use cases. Really what organizations need to think about is what we call code to cloud visibility, which is combining those really strong practices in observability and monitoring, which creates depth in your delivery chain, with breadth, which is all the telemetry that comes from the delivery chain itself. Again, that application of applications, and making sure that we have all the visibility that supports observability, but also all the understanding and all the learnings that come from that. And again, this doesn't incorporate the feedback loop, which is unfortunate because it's really hard to do in slide decks. I've tried many times. But that learning is important. And Dave, why don't you give a quick example of like what can you learn from, what happens in production that would feed back into coding and planning?
So there are two things that are kind of natural that come into that category. One, and something that most people tend to ignore a little bit, is you can learn a whole lot about how you are successfully testing your environment. So, and this is one that always amazes me when people don't do it, is that quote, testing for production is not the same as running in production. And again, by closing that loop, you can get closer and closer to actually getting a test for production inside of that. The other is that you start learning, just like we have service maps for requests going through a system, you end up with a sort of a service map for requests that are going through your developers, DevOps, and ops cycles inside of here. You start learning what is efficient and what is taking the longest amount of time. So, in a sense, I've spent a lot of time working with our APM product for this. You're going to have the same impact in understanding what your teams are doing and how they are operating as the same points.
Yeah, that's absolutely right. And what's cool is you're talking about it again in terms of your delivery chain is an application. The customers of the
Yes.
delivery chain is your developers first and foremost, but the entire company really. And it is an application and it should be treated as an application. So what is pipeline analytics? Let's get into the tactics a little bit here. It's monitoring your SDLC. And I'm going to go into details of what that actually means here in a second. It's creating value streams and KPIs from your delivery chain. And it is bringing in this concept of audit and compliance to protect you from bad actors getting access to what's happening in your delivery chain and doing potentially like what Dave said, even manipulating it to the point that they can take advantage of it in production. Tools are a big part of this because the data for this often comes from your tools, all driven by automation. In DevSecOps, you have tools like X-Ray, Nexus, HashiVault. In CI/CD, you have Jenkins, Spinnaker, all these automation tools, workflow tools that come together to automate your delivery chain. There's a ton of testing tools out there. I just put a few examples, but you have functional testing, you have PyPy, you have all these amazing tools that you use to test your code to make sure that it meets the quality standards before it hits production. You have orchestration tools like Chef, Puppet, and Salt that lay out your infrastructure, and they have to be up and running as well. And then you have the SRE, the incident response side, with your on-call tools.
One thing I want to add here, just because it's possible to get confused. When we talk about orchestration here, we're talking about orchestration differently than we talk about it with container orchestration.
Mm, yeah,
So
good
that's
point.
why when we hear orchestration, we're not showing things like Kubernetes and those in here. Those are actually inside manipulating, in a sense, running environments. Here we're talking about how we bring the pieces together. So just keep that in mind that orchestration is a slightly overloaded term here.
Yeah, it really is. And yeah, I appreciate that. Uh, that's good. All right, so how do you do this? It's not trivial, but it's also not like understanding the capabilities of how do you get there is not all that complicated. You're going to gather metrics and logs from your tool chain. So this is the telemetry coming off of your tools. Different tools have different types of data that will determine how you collect it and visualize it. You're going to correlate that data across teams and use cases. And also, you need to build a strategy for compliance and security. You can't just jump into it and expect it to work. You need to work from the data backwards. So, what do you want to be able to accomplish, and what data is going to support you to do that? And it breaks down to three primary use cases. And I think that there might be sub use cases here, et cetera. But every time I look at it, it always is these three primary use cases. First is monitoring. This one's great because we're used to doing this with our applications and our infrastructure. Second is measurement. And let me go back to monitoring. So monitoring is usually done by the DevOps engineers, maybe SREs. Second is measurement. Measurement is data that is valuable pretty much to everybody in the organization, but you may have a lot of data that's more relevant to developers, more to QE, which is quality engineering, more to the production side, which is SREs. But these are your KPIs, right? So monitoring is making sure that Artifactory is up and running, Jenkins is up and running, so you can actually ship code. Measurement is saying, are we doing well or are we not doing well? Finally, you have auditing. Auditing personas could be DevOps, could be your compliance department, could be InfoSec. It could be a lot of people that are probably not the developers. Developers aren't going to care about the audit data all that much. And that is why we divide it into these three key use cases. From an operations perspective, the reason we're doing this is the DevOps engineering team has to meet their SLO for their developers because they're delivering an application. They need to make sure it's running. What's great about this is that it's kind of our standard, what we're used to with monitoring applications. You have infrastructure metrics, making sure that the infrastructure that your Hashi Vault is running on is not blowing up and is supporting the application running, and people have access to it. You have your standard up down. Is the service running? And also here, and this is my injection, but I'm theorizing that this is the case for everybody, that you can leverage red metrics for your services, your SDLC services as well. Now, Dave is a master on red, so I'd love to get his opinion on that.
So actually, I agree with you. Even though Red is really designed for a microservices application, as you point out, we really are looking at applications that are driving other applications here. And anything that is request based can fit into a Red environment. And so, therefore, applying Red to this is actually kind of a stroke of genius. I'm pretty impressed.
Yes, I'm getting cred with Dave. That's the only reason I did this. So next we have the metrics for knowing whether you're successful or not. This is where people get the most excited and there is the most interest. So first of all, recently in the last year or two, Dora Institute was a research organization acquired by Google, created Dora metrics. They're good. You can look them up. I don't have a lot, they're useful. But like everything, you have to make sure that they're meaningful to your organization. I can lay out all these possible metrics for you, but your organization needs to understand again what kind of questions are they going to ask, and then find the data to support it. So for a lot of organizations, Dora is going to do it, but it's not probably going to be an end all be all. There's something else called the flow framework. And it's another thing where I cherry pick what I tend to like and what the things that I don't like. But it is a framework that is useful in primarily understanding how you reduce technical debt. And so I've broken these analytics into categories related to the flow framework. First is flow velocity. So these are the things understanding how fast are we shipping code. The metric I really like here is say do metric, which is from Agile and Scrum, which is your developers committed to building a certain amount of things in a PI, product planning, and how much did they actually deliver. These are going to cross teams, some of them. Some of them are going to be personal to an individual team, kind of like observability, where you have metrics that are application level, everybody cares about them. And then you have some that are layers deep, which are service level metrics, only the service owners care about them, or the people consuming from that service. You're going to find the same thing. That doesn't mean you should create silos. It just means that the data is going to be relevant to different people in different ways, and that should influence how you create dashboards. You have your flow load as well. This is your bandwidth, your capacity, how much is going through your delivery chain. You want to know, is this impacting your ability to release critical functionality? Do you have the capacity to support releasing a certain number of artifacts over a given amount of time? And then the last one's kind of the bummer, but it's only the bummer because when things break, it sucks. But also, when things break, it's an opportunity to learn. I don't like the use of the word failure here because failure happens, things break in every application. In the DevOps environment, they tend to break faster, but they also get fixed faster, which is a huge benefit. So, these are your technical debt and incident data that you want to visualize. And what I really like here is things like cost of downtime. It's a very real, this is how much being down is costing us. Amount of unplanned work. If your developers are on call and they're supporting incidents, that's time that they're not building functionality. All of these are useful, but these are not all of the possible metrics. And these are certainly the ones that get people the most excited. Dave, did you have any to add here?
No, this looks pretty complete. I will add the one snide comment here. Every time I see Dora metrics, I always flash the Dora the Explorer, and
I
see
know.
all these things being carried in a little backpack. So
Actually. All right. So next is the one that's not all that fun, which is compliance and auditing. As we said, delivery chains an application. Treat it like an application. It also means it's part of your attack surface. You need to stop bad actors. How do you do that? You get telemetry from your tools and predominantly the access of those tools. So, for example, are you suddenly seeing a peak in pull downs from a particular repository, which could indicate potentially somebody getting access to your code and intellectual property? Do you see people authenticating to policies like root? Probably shouldn't be using root too often as a policy. If that's happening a lot, that may be suspect. You're looking for anomalies and behavior that you do not like, and you want to address that as quickly as possible. Could be driven by your InfoSec team, could be driven by your DevOps team, but it is all also a part of pipeline analytics. So to close out, just really want to recap. When we talk about this idea of code to cloud visibility, data is the connective tissue. Data is the most critical part. We are very used to and accustomed to talking about observability and monitoring and all these things that we do at depth in production. Those same concepts can be applied to your delivery chain as well in the form of pipeline analytics. And I would argue that it's necessary to have pipeline analytics as breadth to have true code to cloud visibility and really understand what's going on in your SDLC. It has to be shared across teams. It can't be siloed. And you need to tie it to your business value in those three use cases that I mentioned. Dave, did you have any closing remarks for pipeline analytics?
So that's actually, this is also something kind of important. The phrase code to cloud that Chris has been spending some time talking about here is something you're going to need to get to be familiar with, very honestly. As we continue to expand and become more complex, more ephemeral, more driven in clouds and so forth, the concept of code to cloud, where we have repeatable code exercises to deliver, is going to be incredibly important to us. So this is something well worth keeping in your vocabulary list and pulling out to understand what your environments really are trying to do.